The Tea Research Institute of Sri Lanka, TRI Thalawakelle, plays a critical role in the country's tea industry, and one of the biggest costs in their process is fuel. Their fluidized bed dryer system relies on high biomass, or firewood, consumption to dry tea. That high fuel use was assumed to come from a poorly performing radiator, the heat exchanger responsible for transferring heat from hot water into the drying airflow. We're Thermal X, and we set out to find the real cause and fix it. Our first step was visiting TRI Thalawakelle to understand the system firsthand. We recorded the actual operating conditions on site: water inlet and outlet temperatures, air volume flow rate, and drying performance, establishing an accurate baseline for our analysis. Using SolidWorks, we modeled the radiator's exact geometry, a finned tube water-to-air heat exchanger. Then, using ANSYS, we simulated the heat transfer process to see precisely how heat moves from the hot water into the airflow. The results were clear. The radiator operates at an excellent 94.25% thermal efficiency. Water enters the system at 140 degrees Celsius and leaves at 125 degrees Celsius, heating the drying air from 24 degrees Celsius up to the required 121 degrees Celsius. So the radiator itself wasn't the inefficiency. The real problem was upstream, at the boiler. To supply water at 140 degrees Celsius, the boiler must reject flue gases at very high temperatures, wasting a significant amount of combustion energy in the process. Lowering that supply temperature was the key to real fuel savings. Our project progressed through 3 planned phases: baseline data collection, thermal and hydraulic redesign, and system validation. We completed all 3 phases on schedule, achieving 95% of our proposed objectives, correctly identifying the true root cause of TRI's fuel consumption and delivering a validated, implementable redesign. TRI made clear that they couldn't overhaul their entire boiler system, so we focused on a solution they could realistically implement: redesigning the radiator itself. After completing detailed thermal and hydraulic calculations, we proposed increasing the radiator from 12 to 14 tube banks, allowing the boiler to operate at a reduced inlet temperature of 135 degrees Celsius instead of 140 degrees Celsius. Here's the engineering behind it. Lowering the water inlet temperature reduces the temperature difference driving heat transfer, known as the LMTD, or log mean temperature difference. With a smaller LMTD, less heat would normally transfer for the same surface area. To compensate, we needed more heat transfer surface area. Our calculations showed a required increase of approximately 15.8%, and adding 2 extra tube banks provides almost exactly that additional area, giving the water a longer flow path and greater residence time inside the radiator. This confirms the redesign maintains the required 468.9 kilowatt heat transfer rate with a new water outlet temperature of approximately 119.2 degrees Celsius, matching TRI's drying requirements with a lower temperature, more fuel-efficient boiler operation. We didn't stop at the thermal side. Adding more banks also increases resistance to water flow. We calculated this increase at approximately 16.7%. To maintain the required flow rate of 30 cubic meters per hour at 16.45 meters of head, the circulation pump needs to be upgraded. We identified this as a necessary supporting modification, ensuring the redesign works as a complete system, not just on paper. Beyond the radiator redesign, we also explored a more ambitious, longer-term solution: converting the entire system from hot pressurized water to steam. At 6 bar gauge pressure, steam's latent heat of vaporization can deliver the same heat duty using a smaller, more efficient heat exchanger. Our calculations showed this approach could reduce biomass fuel consumption to an estimated 214.5 kilograms per hour for the same drying output. While this isn't practical for TRI to implement immediately, given their current infrastructure, we fully validated it, from heat exchanger sizing to piping and condensate recovery, as a strong recommendation for future upgrades. Through precise measurement, modeling, and engineering analysis, Thermal X delivered a practical, validated radiator redesign for TRI Thalawakelle's tea drying system. Thank you.